Hello friends, myself Digambar Padet. Today we are going to learn the topic that is stress strain diagram for ductile material. Okay, the topic name is stress strain diagram for ductile material. For knowing this topic, we should know the concept of ductile material. Okay, there are two types of material, that is brittle material and ductile material. Firstly, know what is brittle material. The material which is directly broken into two parts or number of parts without any deformation. If there is no deformation in material and material is directly broken, then the material is known as a brittle material. Okay, this is concept of brittle material. Now we have to know the concept of ductile material. What is ductile material? The ductile material possesses the property of elasticity. That means ductile material must have the property of elasticity. Then what is elasticity? When material regains its original size and shape on removal of external force, that material is called as a ductile material. For example, rubber. Okay, after we given the external force to the rubber tends to the extend its size. After removal of that force, rubber comes to its original size and shape. That means rubber has the property of elasticity. That means rubber has also the property of ductility. Okay. What happens in metals? Metal tends to extend. So all metals have the property of ductile material. So we have to know what is the effect of external force applied on the material when it is applied to the load. Okay, this is stress and strain diagram for ductile material. Okay, there is a number of points which gives the relation between stress and strain. Okay, this is basic curve for ductile material. Okay, let us start from first stress and strain. Before starting this point, we need to know some points, that is stress, strain and Hooke's law. Okay, basically what is stress? Stress is force per unit area. Okay, the force applied within per unit area is called as a stress. Okay, then strain, what is strain? The strain is the ratio of change in dimensions to the original dimension. When you apply the force on the material, the dimensions of material change. Okay, that ratio to the original dimension is called as a strain. And the last point we require to know this concept is Hooke's law. What is Hooke's law? Hooke's law states that within elastic limit, stress to the strain ratio is constant. Okay, what is Hooke's law? For elastic material, within elastic limit, stress to the strain ratio is constant. Okay, these basic three terms are required to know for knowing this diagram. Okay, let us start the stress strain diagram for ductile material. Okay, this is basic stress strain curve. हागे आहे basic stress strain curve आहे. Okay, बघा. At x-axis there is a stress and on y-axis there is a strain. Okay, so directly that this diagram gives notify us the relation between stress and strain. Okay, from point O to A. Okay, when we see this diagram clearly, point O to A, there is a straight line. From point O to A, there is a straight line. That gives us idea stress is directly proportional to strain. Okay, stress is directly proportional to strain. After point A to B, the diagram tends to curve. After point A to B, the diagram tends to curve. That means only up to point A, the stress strain diagram for ductile material follows the Hooke's law. That means within elastic limit, stress is directly proportional to strain. From point O to A, that region is called as a proportional limit. That point is called as a proportional limit because from point O to A, stress is directly proportional to strain. Okay, so up to point A, the ductile material curves follows the Hooke's law. So this region is called as a proportional limit. Okay, after point A, B is a elastic limit. After point A, the next point is elastic limit. In elastic limit, after point A, there is a slight curve. From point A to B, there is a slight curve. Point B suggests that when up up to point B the load is increased. When up to point B the load is increased. Beyond this point, if the load is increased, body regains its original size and shape. Up to point B, body regains its original size and shape. That means up to point B, the material possesses the property of elasticity. Up to point B, material possesses the property of elasticity. But after point B, material does not possesses the property of elasticity. Up to point B only, material possesses the property of elasticity. After point B, material does not possesses the property of elasticity. After point B, material transfer into plastic stage. What is plastic stage? In plastic stage, material does not come to its original size and shape on removal of external force. Up to point B, material comes to its original size and shape. But after point B, material does not come to its original size and shape. So point B is called as a elastic limit. Okay. Next 2 points, that is C point and D point. Okay. C point is called as upper yield point and D point is called as a lower yield point. Okay. After point C, after point B, the plastic stage is start. That means material have a permanent deformation. Okay, the material does not come to original size and shape after point B. Okay, this point C and D refers upper yield point and lower yield point. That means these 2 points have a permanent deformation. Okay, up to this point, material totally comes in a plastic stage. Okay, next point is E point, that is ultimate stress. Okay, what is ultimate stress? Ultimate stress is the maximum amount of stress that can be developed in the elastic material or that can be developed in the ductile material. Okay, for obtaining maximum stress required maximum amount of strain energy. For obtaining maximum stress or ultimate stress, we require the maximum amount of strain energy. At point E, the amount of strain energy is maximum. Okay, the strain energy does not exceed beyond this point. After this point, the strain energy will not exceed. The amount of strain energy developed at point E is the maximum. So we call this point as a ultimate stress. Okay, after point E, material goes in the maximum stress area. Okay, so there is no any deformation will be occurred at point A. Material will be directly broken into 2 or number of parts. Okay, due to the maximum deformation occurred at point F, material will be broken into number of parts or maybe in 2 parts. This point is the last point of this curve. It is noted as a breaking point. Okay, so there are 6 points from O to A. There is a proportional limit. Point B is elastic limit. Up to point B, there is a elastic properties. After point B, there is a plastic stage start. Point C and D gives the data about yielding. That means there is a total plastic stage is done. E is the point where maximum stress energy is generated. For obtaining maximum stress energy, we require the maximum strain energy. So this point is called as an ultimate stress point. After point E, the breaking is occurred in the component. So this point is called as a breaking point. What is the conclusion of this total part? That means for a ductile material, at some stage there are elastic properties. After some stage, material transfer into elastic properties to the plastic properties. So at some part, material will be broken into 2 parts. Okay. This is the total data regarding the your stress strain diagram for ductile.